Did you ever design a table in Access and were not absolutely sure about how to properly index that table? Or did you design a couple of tables in Access and a couple of queries, maybe a whole application, and you have no idea what I'm talking about? Then this video is absolutely for you. Hi, I'm Philip from codekabinett.com. This video is about indexing tables in Access. And that is a rather boring topic. Actually, I have to admit, I did not really want to make this video. I plan to make another video about query performance, which is probably much more interesting. But while writing the script for that query performance video, I came again and again, I came back to the topic of indexes. And it is basically almost impossible to explain query performance beyond a very superficial level without touching indexes. And so I came back to the index topic again and again and again. And after a while I thought, no, this makes no sense to always go back to the index topic and wander off in that topic when there is no proper video to explain that. So I deferred the other video. I hope I will be recording that soon, but I feel I need to make this video about indexing. Indexing your database makes the difference between a blazing fast application and a sluggish, crawling, slow thingy that is unpleasant for your users and does not meet their expectations. So, to get started right away, let's take a look at how indexing works on a very abstract level. Okay. This demo might be a little bit silly, but I hope it will illustrate the way the database engine has to work when processing a query. Yes, I'm fully aware this is Microsoft Excel, it's not a database. But just assume I am your database engine now and you instructed me to find all records in February 2018 in the column production date, this column. The date is my local date format, so it's day, month, year. And you did not help me with the task by providing an index. So there's no index here, and now I try to find all the records in February 2018 as fast as I can. Okay, go. So it is a little bit tedious. I need to scroll because there are quite a few records in here. Okay. Well, I think I got them. Now let's just select them. Okay, done. That was, well, I did not have a stopwatch running. I do not know how long it took, but it was tedious. I might have missed a record and it took some time. That was because I had no index to help me. And that is what we are comparing to this experience right now. This was the whole table. It was only sorted by the ID column here, the primary key. And I had to pick out all the date values that match your criteria. And it was not too difficult because there were only about 50 records in here, or 60 records. And yeah, they were pretty close together. So it was a rather easy task, but I was struggling nevertheless. Now I switch over to this sheet. And now assume there is an index on the production date. And once again, I try to find the records in February 2018 as fast as I can. And here we are. I forgot to add the filter here. And this was. So let's try the same with an index on my production date column. I prepared that in another Excel sheet. And now there is an index on the production date column. And as I did before, I'll try to find all the records in February 2018 as fast as I can. Okay, here we go. All right, that seemed to be pretty easy. Done. I have no idea how the times for execution compared, and frankly I don't care because this is just a silly example, but it was much easier for me to find these records, and I'm pretty confident I did not miss a record I should have selected now, but I'm not so confident in the previous example, and if I would have to be absolutely certain, I would have taken even longer than I did. So you can think of an index like a sorted representation, and I intentionally included only these two columns here. It's a sorted representation of your table, a copy of the data, so to say, where this is my index field and the data is sorted by the index. So it's very, very easy to find particular records in the index. Of course, there is another step to process afterwards. In the sheet with no index, there I had all the complete records, all the fields from the records, even if there's only junk dummy data in here right now. I had that right away. So after I really filtered by the production date, I was done. I had the final results. With the index, I only get the indexed value and an identifier of the record, and I would need to add an additional step afterwards to get the whole record after querying the data. But nevertheless, it is much, much faster. We have seen quite clearly what the difference between an indexed column and a non-indexed column is by me trying to be your database engine, and it should be pretty obvious that it makes a huge difference regarding performance. And performance is the main reason for indexing your tables. And we are looking at another example in a minute, but before we go to my screen, I would like to share a little bit of background information. I actually had to blow up my demo database quite a bit, move it to a network share and blow it up quite a bit more because I'm recording this video outside normal business hours. So there's actually in our office network there's no traffic at all, and the file server the backend is sitting on is practically idle, it does nothing, and I've got a very powerful machine. So I had to create quite a big database table to show you real differences in performance with some queries in Access. But that is a mistake that developers frequently make. They work in this sort of environment where they are the only user in the database, they have a rather small dedicated network, and they have very little test data. And then, under these circumstances, every query is fast. And that is not how you can really design your application for performance. You need to keep in mind that your users in the production database will enter more and more and more data, and after a year or maybe 2 years or 3 years those queries you designed with a nearly empty database and tested under ideal conditions is going to be pretty slow. And maybe in your development environment you think, yeah, the difference between the index table and the non-index table, oh, it's negligible. It does not make a big difference. But that is a wrong conclusion, because the difference will be enormous when there is much more data in the database. It will be even greater when there are multiple users working with the database at the same time, and when your network is clogged up because lots and lots of other applications are using the network as well, and you do not get the same bandwidth like in your development environment. And the absolute worst is if you test on your local machine, you put the backend, the data file on your local machine, then the data does not need to travel across the network and operations will be much faster. But that is not what will happen in a multi-user scenario. Then you will have to use the network. And this makes a fundamental difference. So always keep that in mind when you see performance is very good in your development environment. You need to simulate at least a decent volume of data in your tables and then try for performance. And if you want to push that to another level, you can try to throttle your network to a lower bandwidth and then try again. It's maybe a little bit overboard, but you have to keep in mind that your end users that will be working with the applications will have much less optimal conditions than you have as a developer. Okay, that being said, let's look at how to create indexes. So this is the little sample database I created. It does contain only one table, and that is a linked table. In the backend, the database containing the data sits on a network share, and it is linked into this database, which is on my local disk. That is actually the recommended setting for Access databases used in a multi-user environment. And you see that it is a linked table by that small blue arrow at the top left corner. So it has a couple of fields. The ID is the primary key, and these are some numeric fields. This was actually a text field, but I had to anonymize the data because I copied that over from a production database. This one is a date, and these are just some filler fields I added here to have a more realistic width of the table, to have some additional data in there. So you see right down here, there are nearly 7 million rows in this table. As I mentioned a minute ago, I needed to blow up the database to show meaningful differences between a non-indexed table and the indexed table. This is a bit extreme. You will probably not have so much data in an Access table, but you might have. So let's look at the query I prepared. It is pretty simple. I just query the whole table, like with a star symbol here, and then I put two criterias on my query. I filter just for one single day, the 1st of January 2018, and I only want to see records with a product ID of less than 10. I'm not running this query directly, but I created a little module that is going to run the query, and I show the module to you. Here it is. It does record the start time, then it does open the query, very simple, and I move to the last record in that query. That is quite important because quite often you see a query performing rather well. It shows a couple of records and seems to be completed, but if you scroll to the last record, that might take another couple of seconds. So to really compare performance, I scroll or I move the cursor to the last record in code. And then I record the execution time simply by comparing my start time to the current time, and I output the execution time of the query. So there's nothing special in here. It's just a little helper to have comparable results and to record the time for execution. And that is not particularly accurate just on second level, but I think it should be enough to visualize the differences. And I'm going to run the function I showed you via this macro, and that is only because I can just double click the macro here in the access view without having to go to VBA. Okay, let's see how this query performs. And you see something is happening, but we don't see any data yet, and it's running and running and running, and it just finished after 10 seconds. Not too bad considering the number of records, but as I said, I've got a gigabit Ethernet network and the file server is basically idle. My local machine is quite powerful, so that are ideal circumstances here. Okay, we got the result here. That is the before indexing result. Now, I closed this database because this is a linked table, and I'm now going to change the table, and that has to happen in the backend database. And this is a copy of the backend database on my local disk. It's not the one on the network, but I'm going to open this one. They are identical, I swear to you. Here we go. We are not interested in queries and modules here. I'm just opening the table, and you see it's not a linked table now. The blue arrow is gone. I open this in design view. And that is the table we just had. And now I go to the production date column, and I'm going to put an index on that column. And that is pretty easy. I just go down here to the properties. You see it's indexed no. And now I switch that to indexed yes with duplicates okay, because there are many duplicates in that table. And now after I changed that, I hit the save button, and down here you see creating and changing indexes, and that alone takes a while, and that is the main reason why I'm doing that with a local copy of my database, because over the network that would have taken much longer, and I encountered a couple of errors that there was insufficient disk space and whatever. That the messages were nonsense, but the indexing failed for that. And after I copied that to my local disk, I can do that without any issue. In a smaller database, that should not be any issue at all. So now I copy this database to the network share. This is the database on the network share, and I'm going to rename that to no index. And now I paste the change database from my local disk over there. This is the index database now, and now we open the front-end application again. Here we are. This is exactly the same database I used before, and now I run that macro again, and you see it has a huge difference. It is even down to 0 seconds. I was expecting 1 second. This was the most basic of indexes. Now, I'm going to do a little bit more in the backend database here. So we are back in the backend database and I'm going to dive a little bit deeper here. We only used the index property of the column yet, but now I'm going to open the index dialog. And you see, this is the primary key of the table. We leave that one alone. And this is the index on the production date we just created. If I delete this here and close the dialog, you see the indexed property went back to no. Now open up that index dialog again and I create an index production date underscore product ID. And as before, I select the production date here. And now let's look at a couple of other properties in that index. This is not the primary index, that is obvious. It's not unique, that is the duplicates OK we've seen before. And this index ignores, it does not ignore null values. I'm not really entirely sure what the effect of the ignore null is. The documentation says the null values will not be included in the index and the index will be smaller as a result. But actually I was not really able to see any difference, but maybe I just wasn't using the right data with that, because most of the fields in my table in the sample database do contain values. So maybe it was not the right data set to find the scenario where this makes a difference. But actually I have to admit I never use the ignore null properties. I always let it be the default no. And I don't think that makes too much of a difference. So these are our extended index properties. A much more interesting property is the sort order. You can choose between ascending, which is the default, and descending. And in theory, if you just use the index to speed up the selection of data by certain criteria, it should not make much of a difference if you choose an ascending or descending sort order. The descending sort order would be actually better if you would sort your data descending, which is quite possible for a date. If you always want to see the newest records on top, then it would in theory make sense to use a descending sort order. However, while preparing this video, I recognized something very interesting which I did not notice before. It seems like a descending index is completely ignored, at least in all scenarios I tried. It is ignored when filtering the data. So it was completely useless in my scenarios. So keep this in mind. In theory, it should have small benefits, but as far as I could validate in practice, only the ascending index would have had the performance benefits I was showing you. So I switched that back to ascending. And now, after we looked at all the properties, I'm going to select another column here, the product ID. And I once again could choose the sort order, but you see there are no additional properties here, and that is for a reason. These two columns together will be in one single index. And that is beneficial for the particular query I was showing you. I'm going to save the table here. And you see creating and changing indexes. And now I compact and repair. That will take some time. I cut this out. It's always a good idea to compact your database after changing the table structure or the indexes in the database, because that will make Access get rid of all the old stuff and actually decrease the database size. So finally, I copy my local database back to the file share and replace the existing file. And finally, I can open the front-end database again. And now I run the performance test again. And well, the difference in this message box is non-existent. It is still 0 seconds. But I think you might have noticed the query opened even faster than before. And that is for a reason. If we go back to design view, you see we've got the production date here to filter on. And we got the product ID. And now both of these columns are together in one index. So this is super efficient indexing for this particular query. Both criteria fields are in the index. Access just needs to look at the index to completely select the data and then only output the matching records. We're going back to the backend database. Here we are. I'm going back to the index window pretty fast. This has been alphabetically sorted. That does not make a difference. But one thing I would like to mention. I deliberately put the production date first in the index, reading from top to bottom, and the product ID second. And that is for a reason, because the production date, one single day, will have between 20 and 50 records per day. But if I would only filter by the product ID, that would be between 500 to 1,000 or even more records for one single product ID. If you think about the order of fields in your index, you should always put the most selective field first. The field that narrows down the number of records most. That is the one that should be first in your index. And any additional fields should come in the order of their selectiveness. We have seen quite impressively what difference in regard to performance proper indexing of a database table makes. That is usually the main reason people talk about indexing database tables. But there is a second reason that often gets overlooked. A second reason to index your database tables. And I showed you that there is a unique property in the index, and that is usually not needed because you got your unique primary key and you will most likely not index another single column uniquely. There might be rare reasons where you use an internal customer ID in your database and then have an external customer ID that is maintained in another system that you do not really use for joining tables in your database, but it should still be unique. But with an index, with two combined fields, you can protect the data integrity of your database. A couple of days ago, I was asked from someone about how to ensure the uniqueness of two combined fields in a table. It was about a room management database where there was a room number 1, room number 2, room number 3, and in each room there were desks and they were numerated 1, 2, 3 in each room. And of course you only want in room 1 a single table with number 1 and then number 2, but it must not happen that you have 2 desks or tables with number 1 in a single room. And you can achieve that by creating a combined index on 2 fields that is unique. So both values together, the combination of the values is unique. And that is what I'm going to show you now. So we're back in the backend database. I open the table once more and go to the index dialog. And I just modify this existing index. I build those multi-column indexes. I build their name by appending their fields or a short form of that field. And I insert another row here that was at the wrong place. You can just move around the rows in here as you like. They are only persisted when you store the table. And I add a third field in here, the production name field. And now I have to use these 3 fields because otherwise I would have duplicate data in my sample database. So if I'm going here and say this index is going to be unique, then there should not be any duplicate data in there. I save that, and once again the indexes are created. I skip that and I'm going to do a compact and repair afterwards. So I just created the index, compacted and repaired the database, and I would like to show you an interesting detail. I did a compact and repair, and this is the current file where I just created the index, and that is the original database file without the index. I did not change any data inside there, and you see it's more than 100 megabytes bigger than before. And that is the additional space this index takes on such a big table here. And the difference becomes particularly notable now as I build the 3-column index, because the 3rd column I added was a text column with text data in it, and that needs the most space compared to the date and long integer fields we had before. And now I changed data in here. I changed the product ID to 3, that still works, and now I changed the product name. And now we've got duplicate data. The primary key is still different, but you will see the error message in a second. These 3 columns are identical, and if I now leave that to update the record, I get this error message. I cannot save the data because it would create duplicate values in my unique index, and that is of course not permitted. So I cannot save this data. If I change just 1 digit in here, it's not a problem anymore, but it prevents duplicates, and it prevents these duplicates on table level. That is really important to notice. That is much better than preventing them on form level. The form level checks are still useful to give meaningful error message to the user to warn him as early as possible about the problem, but in the end there should be a check on table level if this integrity rule, this uniqueness rule is important to your data. We have seen the benefits of indexing your tables, and this is very important. You should absolutely know about that. But there is one question left. Does it hurt if you create too much indexes, or if you create the wrong indexes? Yes, this can hurt. I showed you the size difference of the database. So if you create an unnecessary index, the database might grow and you do not have any benefit of that. That is a nuisance, but with huge tables it might be quite a difference. And what are good fields to index? What are bad fields to index? Usually good fields to index are fields with a high cardinality of data, with lots of different values that an index narrows down the data quite a bit. And in contrast to that, it would not make much sense to put an index on an yes-no field, because you only have two different values. That is not a good field to index. Unless, and you always have to look at the particular requirements, unless you have a database where in that particular yes-no column 99% of the records are no and only 1% of the records are yes, and you want to filter for the small number of yes records, then an index would actually make sense on that field. It would still be beneficial. But if you have an even distribution between yes and no, then an index on that column would not make any sense at all. And as a very rough rule of thumb, I would say the moment an index or a query for one particular value in the index does not narrow down the data to less than 10% of the data in the table, then it does not make too much sense to put an index on that column. That is really a rule of thumb. You need to check your particular requirements, your database, your queries. There's no general rule to say this field has to be indexed and this field has not to be indexed. You can have a super selective field with almost unique values, but you never use this field in a query, like a timestamp field when the record was entered. You never query for that, or rarely. Then it would not make much sense to put an index on that field. You should always think about your application, what your application does with the data, what kind of queries are run against the data. And that is the important part to consider when thinking about indexing. You cannot say this column is good to index. No, you always have to look at your queries in your application, and with those queries in mind, then you can say, yeah, this column or these two columns, these three columns, they are good candidates for indexes. And in the end, you should always try if the indexes make any difference. And once again, it is important to have a meaningful volume of data to try that. And with that said, there is one more way in which indexes can potentially hurt. If you create an index on a bad column, a column that is not really suitable for speeding up your queries when indexed, it might confuse the query optimizer, the part of the database engine that looks at your queries and tries to figure out how to most efficiently work on those queries. This part of the database engine might get confused when seeing an index. It might think, oh, great, I want to run this query. There's an index. I use this index to produce the results for the query, and the index is bad. And the database engine actually needs more time using the index than it would have using a different index or no index at all. So keep that in mind. Do not just index everything in your database. That would be outright wrong. Index the right columns and check if your indexes make a positive difference. And there is a tool for that can help you with that, but that is really expert level knowledge. It's a bit hard to handle. It's called JET Show Plan. That is a registry switch for the JET or ACE database engine, and that will force the database engine to output its query plan in a text file, and it's pretty hard to read, so that is really an advanced technique. But when talking about indexes, I think I need to mention it. And by looking at these text files, you can see which indexes were used and how the database engine processed your query. But that is hard to read. It's not for beginners. It's probably not for intermediate. It's if you want to do advanced query tuning. I'm going to put a link down there in the description how to find that, because it's actually not that easy to come by the information about that. Okay, we are at the end of this video. It is much longer than I thought before, and so let me ask you a question. Do you think these long, extensive videos are good? Do they have a benefit for you, or would you rather prefer a short video just showing the top level information and not drilling down so deep? Let me know in the comments below. Do you want long videos? Do you think it's good to have it such extensively covered, or would you rather prefer a short overview of the topic? Or maybe both? I don't know. Let me know in the comments. Thank you very much for watching. If you like my content, please subscribe, like the video. Thank you. Bye for now.